All right, so today we're going to learn about the standard normal distribution, which we've already talked about what it means for something to be normally distributed, but we haven't talked about the standard normal distribution. So a couple definitions that we need to talk about first. The first is a density curve, which is the graph of a continuous probability distribution. I wonder if I can move that up or not. Nope, apparently not. So anytime we have a continuous probability distribution, we're going to have a density curve. The important thing about density curves is that what happens is that we end up with a relationship between probability and the area under that curve. And because the total probability of anything, the sum of all the possibilities we know is 1, that means that the total area under a density curve also has to be 1. So let's type that out. All right, there we go. So total area under a density curve has to be 1. We are going to look at 2 different types of distributions in lesson 6.1. We're going to look at uniform distributions and we're going to look at the standard normal. So standard normal is the more common distribution, which is why the section is titled after it. But we also have the uniform distribution as well. So a uniform distribution is when the values are spread evenly over the range. So the reason it says uniform is because the probabilities are the same consistently for the entire set of possibilities. Because of that, when we are looking at a uniform distribution, the shape of the graph is a rectangle. Because as you're going to see when we look at some examples, because the probability is consistent, it's going to have the same y value every single time. So we know that in a rectangle, the area equals the length times the width. And so when we're looking for specified probabilities, we actually just use that rectangle area formula. I'm going to underline these since these are the definitions that we have. So a uniform distribution, if we were looking at it, whatever the probabilities are, let's say that our first possibility is x1 and the last one is x2. Because the probabilities are consistent, the probability of x1 has this value, p, whatever it is, and everything from x1 to x2 has that same height because the probabilities are uniform. They're the same. The values are spread evenly over the range. So it looks something like this. Then we have the standard normal. distribution, where we have the bell shape that is symmetric about the center. So just like we talked about normal distributions before, not only does it go from low to high back to low, but it should be symmetric around the center. On a standard normal distribution, so we've added in that word standard because before we just said normal distribution. When we add in the word standard, what that does is it tells us that our mean is going to be 0 and our standard deviation, it won't click for some reason in the place I want it to. There we go. It will not let me type. So the mean on a standard normal is 0 and the standard deviation is 1. So if it says standard normal, that is always true. You don't have to have any more information to know the mean and the standard deviation. Our last definition is critical value, which we have already kind of talked a little bit about critical values when we did the section on linear regression and linear relationships. Because we use the critical value method. But a critical value in general is a z-score that is on the borderline separating scores that are significantly high or low. And we'll underline that one too. So when we talk about like the range rule of thumb for finding values, we have the mu minus 2 theta and mu plus 2 theta. Critical values are not the same as those, but it's the same idea. Whereas with range rule of thumb, the borderline for significantly low is mu minus 2 sigma. We have the same idea with critical values. We will have a z-score that is specifically saying values that are below this z-score are significantly low, values that are above this score are significantly high. Okay, so we're going to take a look at some examples for what you may see in your homework. So let's take a look at first example. So subway passenger wait time between 0 and 5 minutes is uniformly distributed. That's how we're going to start that. And what we want to do is find the probability that your wait time is, and then we're going to look at two separate choices. A, greater than 1.25 minutes, and then B, between 1 and 3 minutes. Okay. There we go. I'm gonna pull up colors here. Okay, so obviously the key in this problem is that it's told us that it's uniformly distributed. And that's going to be really important. And so if we want to draw the situation in a graph, which really is what you need to do to be able to solve these on a uniform distribution, really on any of these, we're going to draw a picture. When we have a height, for a uniform distribution, it's always going to be 1 divided by the range. Because that's going to be the probability of each individual piece. So in this case, we have wait time between 0 and 5 minutes. So from 0 to 5, that range is 5, and every single minute has to have that same probability, which means 1 out of 5 probability that you wait 1 minute, 1 out of 5 probability that you wait 2 minutes, so on and so forth. So when we draw the picture here, our height is going to be 1 divided by 5, which is also 0.2. So here really is what our picture looks like. The entire probability is what would be inside the rectangle. And again, we have from 0 to 5 as our input values for the wait times. And the height is going to be the probabilities, which each of them is 1 out of 5. So this entire rectangle's area represents a probability total, which is 1. So if I want to know the probability that our wait time is greater than 1.25 minutes, because there is a correspondence between probability and area, that means this is 1 right here, if I find the area of greater than 1.25, which 1.25 is probably about right there, if I find this area here, that's going to equal the probability because there's a correspondence between probability and area. So what I need to do then is to just use the area equals length times width. So probability equals length times width. So length is going to be from here to here. Width is going to be from here to here, which we can clearly see that one is 0.2. So from 1.25 to 5 then is a length of 3.75. So I've got 3.75 as my length. I've got 0.2 as my height. That means that probability of x greater than 1.25 is going to be equal to the area, which is 3.75, times 0.2, which gives me 0.75. So for the next one, it's the exact same idea. If we draw our picture, the entire area looks the exact same because it's the same exact situation. So here's the whole rectangle. We want to know the probability of the weight being between 1, which is here, and 3, which is here. So this shaded area right there. And again, our probability is going to equal the length times the height. Of course, you can see this is clearly not drawn to scale because we have different scale on each axis. But this is 2, and this is still 0.2. So our probability of x being between 1 and 3 is going to equal 2 times 0.2, which gives us 0.4. All right, hopefully that makes sense. Now we are going to take a look at an example with the standard normal distribution. So let me type out the next example here. Okay, so here's our example. We want to find the probability that a randomly selected subject has the given score if results are normally distributed with a mean of 0 and a standard deviation of 1. So the fact that it says mean 0 and standard deviation 1 is what tells us that this is a standard normal distribution. Now, of course, sometimes it will actually say standard normal distribution. Sometimes it will say exactly like it does here with just saying the mean is 0 and the standard deviation is 1. Now, these ones are finding a probability. So remember, like we said way up here, there is a correspondence between probability and area. So if it is asking us for a probability, that means it really is also asking us for an area. So I said that all of these, we would pretty much be drawing a picture. So if we have a normal distribution, we know it's a bell-shaped curve. Because they told us so, we know that our mean is 0 and our standard deviation is 1. So what we are trying to find is we are trying to find the space. So less than negative 1.23 would be like somewhere over here, right? So if this is negative 1.23, if we want to know the probability that a score is below that, what we're doing is finding this area, because probability corresponds to area now. So we actually do these in our calculator, and anytime, because really in many sections for the rest of this semester, are we going to be finding areas like this under some sort of normal distribution. So when we have this, anytime we're looking for an area, we're going to use very similar prompts in the calculator. So what we are going to do, and I'll show you on my calculator here in a second, but I'm going to have you write out the prompts here. We are going to go to second, and then we're going to hit vars, because again, we're going to distributions, and when you hit second vars, that's distribution. We are going to choose choice 2 in this case, which is normal CDF. This should make sense because when we did binomial PDF and CDF, CDF was for the less than or equal to. And so we said it was cumulative. So this is cumulative because it's going from the very far left side all the way up to a specific number. When we do this, it is going to ask us for some values. And if you have the newer operating system like my online one does, then you'll get to, have prompts given to you. But if you have an older calculator, it's just going to go back to the home screen and say normal CDF, and then you have to know what to type in next. When we choose normal CDF, what we're going to type in first is whatever the lower limit is. Then we're going to put a comma And again, the newer operating systems, it'll give you prompts for these. But for older operating system, you have to put a comma next. Then we're going to put in the upper limit. And then we're going to put in the mean, which of course in this case is 0. And then we're going to put in the standard deviation. All right, so let's try this on your calculator. All right, so following the prompts we had written down, we're going to press second and then vars to go to the distribution menu. Now we are going to choose choice 2 for normal CDF, so normal cumulative distribution function. We are going to enter our lower limit because really the lower limit is negative infinity. So I just enter negative. Make sure you use the negative key, not subtraction, or you'll get an error. But press negative and then just put bunches of 9s because that'll get you, close enough to negative infinity for the calculator at least. In this case, our upper limit is negative 1.23 because, again, lower limit is the left side, which is negative infinity, and then upper limit is negative 1.23. The mean is 0 and the standard deviation is 1. So if you have the newer operating system, you can enter those prompts, press enter. If you have the older graphing calculator, again, you won't get those prompts. You'll just have to type this in yourself, the negative 9999999, comma, negative 1.23, comma, 0, comma, 1, parentheses close, and then press enter. And it finds the probability for us. In general, again, we round probabilities to 3 significant digits, which in this case would be 0.109. So that is what we will enter here. So 0.109. So just like when we were doing the binomial probability and I gave you the choice of doing it using the formula or doing it in your calculator. Here we are not doing them by hand. It is all the calculator, but this is your work. You need to write out what you used. So normal CDF, lower limit, upper limit, 0, 1. So that I know what you pressed in. That's your work. This is the answer. Please do not give me homework problems that do not have work. You will definitely lose points on it. You need to show your work. Okay, so then between 2 and 3, if we're drawing the picture for that, and I really would get in the habit of drawing the pictures, just because when we get into later sections, it's going to be really important. It's going to be very hard to visualize some of the things if you don't draw a picture. So here's our mean. So since our standard deviation is 1, here would be 1 standard deviation. Here's 2. Here's 3. And so what we are trying to find is the probability of being between 2 and 3. Which would be this area here. Again, when I'm asked to find a probability, I am really just finding an area. So on this one, for my work, I would do normal CDF, lower limit of 2, upper limit of 3, mean of 0, standard deviation of 1. So go back to my calculator. Maybe, where is it? There it is. So second distribution, normal CDF. This time my lower limit's 2, my upper limit is 3, my mean and standard deviation haven't changed. Enter, enter. 0.0214 would be 3 significant digits. So 0.0214. And that's our answer. So anytime we are looking for a probability or looking for an area, we're using that normal CDF. Now I'm going to type out example 3, which is going to be working backward. Here we were given the test score or the limits for the test score, and we wanted to find the probability. In example 3, we're going to be given the probability and finding the test score that gives us that particular probability. All right, so find the test score given the area, and in A, we're going to be given a particular picture. Whoa, that's a really bad normal distribution, my fault. This is what we're given, and then in B, we're finding P10. Okay, when we are working backward, we do not use the same calculator prompts as when we're going the forward direction. So when we are finding probability, we use normal CDF. When we are trying to find the value itself that gives you a specific probability, then what we're doing is inverse norm. So this in our calculator is going to be for all of these where we're working backward. We press second, we go to vars, just like we did before because we're looking in the distribution screen, but this time we're choosing choice 3. Inverse because we're working backward, meaning we're given the probability, and norm because it is a normal distribution. And when we do that, we're going to be typing in the area or the probability, and then what the mean and standard deviation are. In this whole section, we're standard normal. So again, mean is 0 and standard deviation is 1. So if I want to do this problem here, what it means is I'm trying to find this. I want to find the test score for which the probability that we score less than that is 0.67. So that's what I'm looking for. So pull up my calculator again, go to second, distribution. Now we're going to choose inverse norm. Again, I'm going to type in the area that was in the picture, so 0.67. I'm going to type in my mean and my standard deviation. If you have the older version, same as before, you just have to know what order to type these in. So it's the area or probability first, then the mean, and then the standard deviation. And so then we can press enter. And again, we're going to round these. Now these are z-scores, so these do not go to 3 significant digits. They go to 2 decimal places because critical values, z-scores, those are always 2 decimal places. So in this case, that would give us 0.44. So z-score would be 0.44. And then here, we'll just put in what you would type in. The area, the mean, and then the standard deviation. So 0.44 is our answer there. Again, you need to show your work. So you need to write out inverse norm, 0.67, 0, 1 as your work. Now this next one is worded a little bit different, but it means the same thing. P10, we did these earlier when we did percentiles. So this is just the same as saying the 10th percentile, which when we're looking at an area where the total is 1, not 100, the 10th percentile in decimal form is 0.1 because 0.1 is 10%. So what we are looking at is, even though they didn't give us the picture, the 10th percentile is the lowest 0.1 of the area. Excuse me, sorry. So if this had been, the 80th percentile, we would have, all the way up to say here, and we'd have an area of 0.8. So you're just converting the percent into a decimal, and that becomes the area. So in our calculator, we are going to do inverse norm of 0.1, 0, 1. So choice 3, 0.1, 0, 1, and enter. And then again, these are representing z-scores, so you should round them to 2 decimal places. So negative 1.28 is what we would have here. Sorry, kind of connected my decimal point to the 2. I can't erase it, but negative 1.28 is our answer. Okay, last example here. Let me type it out. Okay, so when it asks us to find a critical value, what this is really saying to us is that it wants us to find the score with an area of 0.02 to its right. So anytime you have critical value and this, some subscore here, it wants to know the place where it has that area on the right side. So what we need to do then is we need to also use inverse norm. And if we draw a picture, so here's our standard normal distribution. 0.02 is obviously a very small probability. It's a very small area. So what we're trying to do here is find this 0.02. Now, what I didn't tell you in example 3, because we didn't need it yet, was that anytime we use inverse norm, it automatically is assuming that that area is on the left side, because normal CDF, goes from lower limit to upper limit. On example 2, I should have said this earlier, but if you have an area, let's say, that went from 2 to infinity, just like we used negative 9999999 as a lower limit to mean negative infinity, positive lots of 9s would represent positive infinity. And so this goes, from whatever this critical value is, which is what we're trying to find, all the way to infinity. And it has a probability, or has an area, of 0.02. But when we do inverse norm only uses areas to the left. So if you put in inverse norm 0.020, 1, you're not going to get the right answer. So what we have to do is we have to use the complement, because we know that if the area to the right is 0.02, then that means that the area to the left of that same spot is going to be 1 minus that, because we know, again, that total probability is 1, and since probability and area are now one and the same thing, we can use the complement. So 1 minus 0.02 gives us 0.98. So what we're going to be typing into our calculator is inverse norm of 0.98 comma, mean of 0, comma, standard deviation of 1. And now it will not hopefully, it will give us the right answer here. If you do the 0.02, it's not going to give you the right answer. So 0.98, 0 and 1, just like this. And then enter. 2.05 would be to 2 decimal places, because again, we're looking for the value. So 2.05. This should make sense because z-scores above 2 are considered significantly high. So you can see that there should be a very small area above that particular value. All right, I think that should do it. Hopefully you can do a good job on your homework. The homework that goes with this lesson 6.1 is the page 240 assignment. So that's what you should be doing.